Greetings, welcome back. Today we're going to be covering experimental probability. Now the difference between experimental and classical, which we'll cover later, experimental is what's already happened. Think of it as like a history. So experimental probability isn't based on what you think should happen, it's based on what's actually happening. So if it rained every day for a week straight in a row, is it going to rain tomorrow? If we've been off for a week and a half, are we going to be off tomorrow as well? And so those are those probabilities of looking forward to what's going to happen based on what's already happened. So experimental probability is just that, it's based on history. All right, so if we look at the history of this example, they spun this bad boy 1,000 times. And they want to know what's the probability that it'll get red on the next spin. And so if they spun it 1,000 times, this is potentially rigged in some way. Maybe there's a coefficient of friction on that spinner, so it slows down on certain things. Normally, there's only one red section out of 4, so it'd be 1/4, which is 25%. But they spun it, and they got 267 of them. Out of how many turns? Well, that's just the thing. We need to figure out what the total is going to be. So what we're going to do is add together 448, 267, and 285. And conveniently, I've done that on my handy dandy smartboard calculator. 448 plus 267 plus 285 gives me 1,000. So since that's my total, once again, we want to do favorable over total. So we're going to do 267 divided by 1,000. And 267 divided by 1,000 gives us 0.267. All right. So once again, we did favorable divided by total. So that was 267 divided by the total, which was 1,000. And we got 0.267. And that's the probability that I want. This can be written as 26.7%. But that's how that goes. Easy stuff. And that's that example. All right. So as we move forward, let's go ahead and take a look at what's going to happen next. All right. Boom, boom. What we're looking at is 100 draws. So if we read through, a marble is randomly drawn out of a bag and then replaced. The table shows the results of 100. So they're flat out telling us the total before we even begin, which they actually said on the last one, but I felt like adding them together. So on this one, 100 draws, estimate the probability that it's going to be a yellow. So this is real simple. Just going to reach in here and grab our yellow, which is 18 out of 100 is going to give us 0.18, which is equal to 18%. But once again, I want 0.8. So this would be the probability of pulling a yellow out of the bag is 0.18. And sometimes we'll put a 0 there. I'm looking for that answer right there, 18%. Easy stuff. You'll have a question just like that on your quiz. Move on to the next one. Same idea. Researchers observing cars passing through an intersection where there's heavy traffic. Of the last 50 cars, 21 turned left and 15 turned right and 14 went straight. So I'm assuming if we add these together, 21, 15, and 14, we end up with 50, which I'm right, it is. Estimate the probability the car will turn right. We're only looking at the turn rights. That's our favorable response. So again, favorable over total is going to be equal to 15. Ooh, that was ugly. Try that again. 15 out of 50. This will reduce down to 3 over 10. 3 divided by 10 is going to be 0.3 or 30%. Again, this is the answer that I'm looking for. So the probability that someone would turn right is going to be equal to 30% or 0.30. That's what I want. All right, easy stuff. I think we might have one more example that we're going to cover, and then we'll get busy on this quiz.